In this lecture, you'll learn about the characteristics of OSPF, and I'll also do a comparison with our other interior gateway routing protocols of RIP and EGRP. So OSPF, it stands for Open Shortest Path First. It's a link state routing protocol as opposed to the distance vector routing protocols of RIP and EGRP. Like EGRP, it supports large networks and has very fast convergence time. Messages are sent using multicast rather than broadcast, so it's more efficient. And OSPF is an open standard protocol. It uses Dijkstra's shortest path first algorithm to determine the best path to learned networks. So that's where it gets its open SPF name from. Okay, comparing OSPF with RIP and EGRP. RIP has scalability limitations that we discussed in the earlier lectures, so it's not typically used in production networks. It's suitable for very small production networks or for lab or test environments. If you've got a lab and you're not testing the routing protocol, you want to test something else, so you just want to get the routing up and running quickly and easily, then RIP is a good choice for that. But not typically used in production networks because of those scalability issues, so that means that your choice for your IGP comes down to either OSPF or EGRP. Out of the two, OSPF is the most commonly used. It supports large networks and it has always been an open standard. It is supported on all vendors' equipment, and there's plenty of support for OSPF, supported by everybody. Loads of engineers understand it and are used to working on it, lots of documentation on the internet, etc. EGRP, however, can be simpler to implement and troubleshoot. But EGRP was historically a Cisco proprietary protocol. It's an open standard now, but there's still very limited support on other vendors' equipment. Most other vendors' equipment won't support EGRP. So, if you wanted the simplicity of EGRP, it meant that you were locked in to using only Cisco equipment. If you wanted to be able to use any vendor's equipment, then your choice would be OSPF. So that's why OSPF has been more popular than EGRP. However, they're both very similar, they're both very good protocols. So if you want the simplicity, maybe you go with EGRP. If you don't want to have that Cisco vendor lock-in, then you can go with OSPF. So OSPF, it's a link state routing protocol. With our link state routing protocols, each router describes itself and its interfaces to its directly connected neighbors. This information is then passed unchanged from one router to another. So that's the difference between link state routing protocols and our distance vector routing protocols. Every router learns the full picture of the network, including every router, its interfaces, and what they connect to. OSPF routers use LSA, link state advertisements, to pass on the routing updates. Our OSPF operations. So when you enable OSPF on a router, the first thing it will do will discover its directly connected neighbors and form adjacencies with them. They will then share routes with each other by flooding the link state database. Once all of the potential routes are learned, the router will then compute the shortest path, and the best routes will be installed in the routing table. After that, the routers will respond to network changes, for example, if any new links are added or if any links go down. Our different packet types that are used in OSPF. First one is the hello packet. As soon as you enable OSPF on an interface, it will start sending out and listening for hello packets, and when it receives a hello packet on that interface, it will form an adjacency with the neighbor. Once the routers have formed adjacencies, they will send DBDs to each other. DBD is the database descriptor. That includes information about all the networks that the routers know about. If a router is missing information about any of the networks it received in the DBD from a neighbor, it will send that neighbor an LSR, which is a link state request asking for more information. The router will reply back with an LSA, a link state advertisement. Other packets types we can have is an LSU, a link state update. That contains a list of LSAs which should be updated. This is used during flooding. So for example, if a new link was added or if a link went down, that information needs to get flooded everywhere with an LSU. And finally, we have the LSAC, which is the acknowledgement message. Whenever a router receives a message from a neighbor, it will send an acknowledgement back. So this makes sure that the protocol is reliable. If a router sends out a packet and it doesn't get an acknowledgement, it will resend it. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.